Hello students, in this session let us learn how the bituminous mix design will be done using Marshall method with the help of some of the numericals. It is given that the specific gravity and weight proportion of various aggregates used in the preparation of the bituminous mixes are given below. The weight and volume of the total Marshall specimen was found to be 475 cubic centimeter and weight of the specimen is 1100 grams. Assuming the water absorption value of bitumen and aggregate is 0, it is required for us to determine the volumetric components of the bituminous mixes, that is VV, VB, VMA and VFP, and they have given that the 4 different types of aggregates are used in the bituminous preparation of the bituminous sample A1, A2, A3 and A4 respectively, and also the bitumen. The weight and specific gravity of all these materials are tabulated in this table. So as the first step before moving to determination of the volumetrics, we need to determine what is the theoretical specific gravity and the bulk specific gravity of the mix. Theoretical specific gravity value of the bituminous mixes can be determined using the expression 100 divided by ratio of weight divided by specific gravity of all the materials that are used in the preparation of the bituminous mixes. We need to calculate separately, determine the specific gravity of the different aggregates as well as the bitumen used in the bituminous mixes. Okay, so substitute the values and we can estimate the GT, and for the given specimen we have got it the theoretical specific gravity as 2.406. Once you determine the specific theoretical specific gravity, find out what is the bulk specific gravity of the bituminous mixes. This can be determined by taking the weight of the bituminous sample in air and taking the weight of the bituminous mix sample in the water. The ratio of W1 Wm, that is the weight of the mix in air divided by difference between the weight in the air minus weight in the water. So this will nothing but it will gives you the volume, though nothing but the value. So using these value, in the data they have given the weight of the sample as 1100 and volume as 475. Substitute and we can estimate the bulk specific gravity of the specimen, and we have found it as 2.316. Using the value of bulk specific gravity and theoretical specific gravity, we can estimate what is the percentage of volume of watts in the bituminous mixes. That is 100 into GT minus GB divided by, or you can take it as GT minus GM divided by GT. Okay, it is nothing but GT is the theoretical specific gravity and GM is the bulk specific gravity of the mix. So substituting all the values, we will get the volume of watts in the bituminous mix as 3.714%. The next is we have found out what is the total volume, and in that volume we have to find out what is the volume of bitumen alone and what is the volume filled with the mineral aggregates. So volume of bitumen can be found as ratio of W by GB, nothing but weight and specific gravity of the bitumen alone multiplied by GM divided by WM, where GM and WM are bulk specific gravity and weight of the bituminous mix. By substituting the given data, we have estimated that volume of bitumen as 20.052%. And once you determine this volume of bitumen and volume of watts is found out, we can estimate what is the total watts in the mineral aggregate. So total watts can be, some of the watts can be filled with the air, that is VB, and the rest of the watts will be filled with the bitumen, that is VB. So substitute, we have already estimated VB and VB, substitute that and find out what is the volume of mineral aggregates. We have got that as 23.793%. So after that, find out what is the watts filled with bitumen. VFB is equal to, so out of the total watts, what is the void that is filled with the bitumen, that is the VFB. So we can find out VB divided by voids filled with bitumen alone divided by total voids in mineral aggregates expressed in terms of percentage. We can estimate what is the voids filled with the bitumen. So similar volumetrics, this volumetrics what you have done, this is for 1% of bitumen. So to determine the optimum binder content, we have to prepare the bituminous mixes using various binder content, and we have to find out the volumetrics VMA, VFB and VV for all the different binder content that has been used. And then we have to plot the graphs taking binder content and the different volumetrics on the y-axis that to determine the optimum binder content. So now we'll see how the optimum binder content can be determined using the test results what we get from the Marshall mix design. So it can be taken from the second example. The result Marshall test results were tabulated in the table below. It is required for us to determine the optimum binder content of the mix. So for various binder content, bituminous mix specimens were prepared and it is tested using the Marshall method. The corresponding stability value and corresponding flow values are determined. So using and also all the VV, VFB and GM bulk specific gravity of the mix, everything is determined and it is tabulated here. Okay, now it is required for us to determine the OBC value. To determine the OBC value, it is required for us to plot some of the graph which indicates that on the x-axis we have to consider the bitumen content, and on the y-axis in the first graph we can take the stability in the y-axis, second graph will be the flow value on the y-axis, third bitumen binder content versus the voids in total mix, the fourth bitumen binder content versus VFB, and in the last graph we need to consider the binder content versus the bulk specific gravity of the mix. So example I'll just show you some representative graph how this will be plotted. So the first one will be the bitumen content versus the density, the bulk density, nothing but the GM value. Though in the first graph we have bulk density versus GM value. The second bitumen content versus the stability value. Third bitumen content versus the flow. Bitumen content versus the voids in the mix. Last bitumen content versus the voids filled with the bitumen. So you can see that as the binder content increases, the density value increases only up to certain point. Beyond that point, density value will reduces. You can see the similar trend in the percentage of bitumen versus the stability curve. The stability value increases up to certain point and further it will reduces. So this is because of the reason as when the binder content increases beyond these 2 points, so the voids in the mineral aggregates, the aggregates portion will be replaced with the binder content. Because of this, as the fluid content increases, the binder content increases, the total stability or the density value will reduces. But flow value increases with the increases in the binder content. Flow value is nothing but the deformation. As the bitumen binder content increases, the mix become less stable, which you can see that the deformation will be higher in such mixes. And as the binder content increases, the total voids in the mix will reduces, because with the increase in the binder content, the VV, the voids, the total air voids what it is there, that will be replaced by the binder content. So as the binder content increases, voids in the mixes will reduces, whereas as all the voids will be replaced with the binder content. As the binder content increases, the percentage of voids filled with the bitumen will increases. So these are all the representative graphs. So now using these graph, how to determine the binder content? So for that we have 3 conditions. Okay, we need to check out what is the binder content corresponding to the maximum bulk density, binder content corresponding to the maximum stability value, and we need to consider the median value of VV, or if median values, or you can determine what is the binder content corresponding to the 4% of air watt. So let us say this will be taken as B1, B2 and B3. Find out binder content corresponds to maximum density, maximum stability and 4% air watts. Then find out the average value of B1 plus B2 plus B3. So what average you will get, that will be the optimum binder content. So for the previous example, we have similar graphs were need to be established, and from the graph it was determined that binder content corresponding to the maximum stability was 5%, binder content corresponding to maximum bulk specific gravity is 5%, and which is corresponding to 4% air watt is 3%. Take the average of all three and we can determine that the optimum binder content value as 4.33%. Okay, so similarly this is how it is we can estimate what is the optimum binder content required in the bituminous mixes, and it is very essential to do the mix design